So as the heading says, this is a review of acids and bases, and I'm assuming, maybe falsely, that all of you have taken a previous course where you covered acids and bases. If not, pay close attention to this. Okay, so acids, let's start with them. Acids generally are chemical compounds with a hydrogen in them, and they react with water. Now, you probably drew these with a one-way arrow. Since it's an equilibrium course, I'm going to write two-way arrow, and it forms something called a hydronium ion and something else, which whatever A was, it was A negative. Okay, and I don't know who taught you this, but they probably told you that this is the acid. By the way, they were right. The acid reacts with water. It made this thing called a hydronium ion. And they may or may not have described this other product as a conjugate base. And if they did, they probably didn't explain it, because what's to explain? We actually have to teach you that in this unit. Okay, so acids react with water to make hydronium ions and something else, which has this weird name. Bases, well, bases, they're quite often negative ions. Bases react with water. In fact, very much like an acid, but then this is where it goes different. The water loses an H plus to the base, and the base forms, well, in this case, it would be HB, which is aqueous. Okay, so we have a base plus water. I guess I can write the word out. And it makes a hydroxide ion. And this thing, you can probably guess, is called a conjugate, which I won't write out, acid. Okay, I'm not sure you ever taught that part, but so bases react with water to make hydroxide ions. And you can write this out for any acid or base. Before we run through any examples, something else you were taught with acids and bases was the pH scale. And we're obviously going to use it quite a bit here. So the pH scale was this scale for determining how acidic something was, and it was an odd scale, to say the least. So a pH was a number from 0 to 14. And as you can probably guess, 7 is right in the middle. Okay. And such a weird scale. Well, to understand what a pH scale is and why it's such a weird scale, you have to know what it's measuring. And what a pH scale is actually measuring is this guy, which is the concentration of hydronium ions, right? Okay, it's just another way of representing this. So let's start in the middle. We'll go back to the 0 at the very end. This would be 1 times 10 to the negative 7 moles per liter. Now, that is water, pure distilled water. And it's also considered neutral. I'm not sure you ever explained to you why it's considered neutral, but it is. And this is 10 to the minus 14, an extremely small number. And that is something that's extremely basic. Which bases don't have hydronium ions, but that's all right. This one doesn't have very many. 10 to the minus 14. Let's go back to the 0. Well, this one was kind of a weird one. One of the most acidic things you can ever come across has 1 mole per liter hydronium ions. You can get bigger than that, but it's extremely rare. And if you write that in scientific notation, it's 1 times 10 to the 0 which nobody does. And it is very acidic. So what in the world is going on here? Well, by looking at these two, you can instantly see what a pH is. Let's start here. See the 7? See the 7. See the 14? See the 14. All right, the 0, I guess it's a -0, but nobody notices. All right. And so a pH is another way of giving you the hydronium ion concentration, because the hydronium ion concentration is an awkward number. It's extremely small typically. And it's in scientific notation. It's got units. The pH doesn't have units. It's just it's a decimal number. And most people remember that pH is calculated by a formula, but pH isn't a formula. But there is a formula for pH, and it's that strange logarithm, which you're possibly taught in math. A logarithm is you take any number and it changes it over to 10 to an exponent, and the logarithm is the exponent. And you can see why it's negative, because the pH is positive, but the exponent is always negative. It just reverses the sign. And if you want to go backwards, if you ever want to find this from a pH, it is 10 to the negative pH. Right? Now, again, if you look at the scale, you can understand what it is. pH is just the exponent on the 10, and we drop the negative sign. So that's how you work backwards. To get the actual number, you take 10 to that power and put in the negative sign. And a logarithm is just a fancy mathematical way of getting that exponent in the first place. All right. And hopefully you realize that as you go down from 7, you're becoming more acidic. As you go up from 7, you're becoming more basic. Now, there's that unanswered question: how in the world do you have a hydronium ion in a base? Because bases don't make hydronium ions. More about that later. Okay, let's add a few more details, because there was more to the pH scale than just that. Because when you have a pH scale, 0, 7, 14, for bases, there's also something which nobody uses very often, but you will have to use occasionally, a pOH scale. And a pOH scale is like the same thing for a base. And it goes from 14 to 7 to 0. So apparently, this is becoming more basic. This is becoming more acidic. Not only do bases have hydronium ions, but acids have hydroxide ions. And actually, they do. Why? Well, let me explain. Something about neutral. Water. Water is our neutral material, not by accident. Water actually is both an acid and a base. Let me write out that reaction. Now, water reacts with water. Okay, this is definitely a equilibrium reaction. And one of the waters forms a hydronium ion, and the other one forms a hydroxide ion. Yeah, okay. Now, being this is an equilibrium reaction, we can write the equilibrium constant. It has a special name. It's called Kw, K for water, or sorry, W for water. And it's a very weird one, because you don't include water in these, do you? And so all it is these two guys, and there's nothing on the bottom. So it's the product of hydronium ions and hydroxide ions. And if you look it up on page 9, it actually has a number, which may, I don't know, trigger some thoughts. 10 to the minus 14. Oh. So for any solution in water, these two guys always multiply to this number. Now, more about that later. For now, there's the Kw. Okay, so acids have pOHs, bases have pHs. and it comes from the water they're dissolved in. So, okay, acids, bases need water. Water is a primary part of acid-base reactions. So there's lots more going on here. I believe there's some practice questions for you, but try those, and if you're having trouble with them, check back with your instructor.